Okay, so continuing with what we've been doing for 1.2. Apologize that I was a little too wordy, but hopefully for people who really lack the foundation, that would have really, got you all set up for the future sections. But anyways, now we are getting to more fun part, which is elimination. It's like playing Minesweeper for like hours, and then you love what you used to hate. But anyways, yeah, so let's do 13 and 14 before we start doing elimination processes. So this one we're particularly interested in homogeneous system, and there is a specific equation where we can decide how many trivial, non-trivial solutions and so forth, right? So I already wrote the question. 13, this is a matrix. So here we have 4 unknowns, right? So, which is x1, x2, x3, x4, right? So because of that, and we also have how many rows? 1, 2, 3, right? So because of that, oh yeah, by the way, when we count the rows, let's say there was a 0, 0, 0, 0, or whatever, right? We don't count the rows with all zeros at the bottom, right? Not that it matters for this equation because we don't have one, but nonetheless. So what we actually say is that, yeah, so we say n, or number of unknowns, it's 4. And how many rows do we have here? So we have number of equations or number of rows, which is r equals to 3. Just saying there's 3 rows, for example, right? So because of that, we do this simple equation, n minus r is the free variable. We'll talk about what that is soon. But nonetheless, so let's do the calculation first. 1, right? So there's 1 free variable in this equation. Not exactly sure what that means, right? So what does that mean? It simply means that because you have 1 free variable, you're gonna have 1 unknown, right? It could be x1, x2, x3, x4. It doesn't really matter, right? But one of them has to be a free variable, which means, I know, like I'm constantly saying, which means blah, 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 which means blah, blah, blah. But nonetheless, free variable simply means it is let's say it was x4, for example, right? It could be any one of those, right? That is going to be a parameter, right? So that's what it really means, right? So, one cool thing that someone showed me, if you have, let's say you had a very simplified solution, right? So this is not reduced or anything like that, so difficult to say. But let's say there was 1, 2, 0, 2, 3. I'm just making these numbers up from a practice round I was doing it with some other person, but 1, 2, 0. Uh-oh, am I getting confused? No, I'm not getting confused. So if I had this matrix, which you can see, yeah, okay. So leading coefficient there's 1. So let's say that was x, y, z, w, and then some number, right? So, and there's a leading coefficient here, nothing else. And then there is one right here. Okay, so I'm just dividing by the column, right? So we're going to use exactly the same thing. How many unknowns are there? 1, 2, 3, 4. 4 unknowns. How many rows are there? Careful. These 2 rows are all zeros. We don't count this, so we just say there are 2 rows that are non-zero, right? So if that's the case, 4 minus 2 is 2. 2 free variable, right? So 2 free variable, like I said. So could be any one of them, but I'm just going to bully W and Z for now, right? It could be any one of those 2, right? Depending on which one you decide to solve first. But because of that, let's say I chose Z and W. Z will be some parameter, and W will be some parameter. And make sure you don't forget to say, I forgot here, these parameters equal to real numbers. Right? So yeah, so that's all there is, right? That's all what it means. This may or may not help you. Now on the question though, they're asking how many trivial or non-trivial solutions, right? So trivial solution is, I don't know why they put it this way. Trivial solution just means whatever your unknown is, x, y, z, or whatever, right? That equals to 0. That's all it really means, right? So, and then non-trivial is so it's the opposite. It's anything but 0. So let's say if x equals to 0, then x is a trivial solution. If y equals to 2, then it's a non-trivial solution, right? So that's all there is. So now on the solution for 13, it says, what does it say? The system has infinitely many solutions. Yeah, well, if you we know that because if it has free variable, you know, x4 could be anything. So depending on what x4 is, you could have a bunch of different x3 possibilities, x2 possibilities, and x1 possibilities, right? So because of that, it's infinite. It's infinite. And if we actually reduce this, I'm pretty sure we're going to get one of the rows is going to become 0 equals 0. So that will prove that as well. But what puzzles some of the people is those include trivial solutions and infinitely many non-trivial solutions. So why does it say include trivial solution and then plural infinitely many non-trivial solutions? Why does it say that? Well, the reason why it says it may have infinite trivial solutions is because let's say the free variable x4, right? So let's say we chose x4. Again, it could be x3, x2, or x1, depending on what you choose. I choose this one because, just because I want to, right? But yeah, so if x4 equals to 0, which is possible because x4 could be any number, right? That's why it's a free variable. It's a macro, where it could be any real number. 0 is a real number. So if x4 equals to 0, then x4 is considered to be a trivial solution. But when x4 is 0, now there's a chance that some of them could be also 0, because we haven't really simplified the equation. But that's why it's saying there could be a trivial solution and many possibilities of non-trivial. Because if x4 is 0, x3 might be something plus x4 or something. So, it's not going to be 0, right? So that's all it's saying. So don't worry too much about the technicalities. The big picture is what I'm talking about here right now. Determining how many free variables you have, understanding what that means, and then use basic trivial, non-trivial terminologies to explain. But again, not the end of the world, right? You just need to know what trivial and non-trivial is so that when you describe these things, you know what you're talking about, right? So again, trivial is 0, means 0, non-trivial. So this means not 0, right? So that's how it is. Okay, so let's try 14. Because 13 seems pretty generic. So let's try 14 and see if that's more interesting. Oh yeah, this is oh no, race cake is a line. That ain't good. Okay. Things go bad when okay, never mind. I need to stop using those weird game references. Okay, that's not the point of this video. 14. So 14 is right here. 1 plus 3. Oh no, what am I doing? Not writing linear equation. 1, 3, negative 1, 0, 0, 0, 4, 8, 1 minus. I'm not lining up properly. 0, 0, 1. Okay, so there we go. And you can put this because we know these are numbers. Again, you don't have to, right? Okay, so this is actually a really great example, right? So 4, 0. Now, be careful. This looks like inconsistency. It really isn't. It just means 4z equals to 0, right? So that means, well, okay, well, can this be possible? Of course, when z equals to 0, right? So z equals 0. So, oh, yeah. And I put c because I say z is, I put unknowns in this context, right? It could be anything, though, right? It could be, it could be OPS, and this will become S. Who cares, right? I like X, Y, and Z though. Reminds me of a Cartesian graph that we used to learn about. But anyway, okay, so that's that, right? So Z equals to 0. This is trivial solution. Like we were talking about, right? So cool. Now, is this all trivial solutions though? Let's see. Next one is y minus 8z equals to 0. But z is 0. So 8 times 0 is 0. Y equals to 0. Another trivial solution. Do you see the pattern here? So it's going to be, yeah, you can see. Okay, so I'm going to write here. X plus 3y minus z equals 0. Z is 0, y is 0, so that's just going to be x equals to 0 again, right? Because that's going to be 0, that's going to be 0, right? So, x, y, z. So, x, y, z. Trivial solutions. All the way. So they're all trivial solutions. So remember the question is, determine whether the homogeneous system has non-trivial solutions by inspection, right? Again, you didn't have to use pencil. You could have just mentally did it. I just did it this way just so that I can explain to you. But again, this is totally trivial solutions, right? No non-trivial whatsoever. So that will be the answer. Oh, and I forgot to do this because I got excited, right? But anyways, let's look at it here. There's no non-zeros. How many unknowns? 3. How many rows? 3. 3 minus 3, right? So remember, n equals to, can you guys see that? Yeah, you can. N equals to 3 and r equals to 3. So 3 minus 3 is 0. So 0 free variable. Does that make sense? Yes, because do you see any free variable which requires parameter? No, z is 0, right? So who cares about the parameter? It's already fixed. So this will be not infinite solution. This will be a unique solution. I said I would try not to review 1.1, but I keep doing it. But you know, again, that's the whole point of doing this, right? So if these are boring you, you can always skip, right? If you haven't skipped already, right? But anywho, that is that. Now, okay, finally we get to do elimination, okay? And this is freestyle. It says use any method, right? So, oh, by the way, oh yeah, okay, no. Shut up and just do your work. 16. Okay, 16, 16, 16, because I'm doing even, because you guys all have odd solutions. So, 16. Yeah, just in the spot. So 16 is going to be 2, 1, 3, 0, 0. Oh, homogeneous. 3, 4, negative 1, 2, 1, 1. Okay. So, what I chose to do here is, what I decided to do is, I like this one. You don't have to choose this, you could choose this as well, right? But I like this one because if I try to make 2 to become 1, then this will become fraction. Try to avoid fraction if possible. Negative 1, that could work too. I could make this positive, but I'm too lazy to switch the sign when I already have a 1 already. So I like this leading coefficient, right? So what I'm going to do, doesn't matter. If you like, I didn't bother moving it, but I'm going to put 1, 1, 4, 0. Eventually this should be going up, right? So, but let's reduce it first and then we'll talk about that, right? So, again, in order to get the negative 1, line 3 plus line 2 will give me 0. Will be the new line 2. So 0, so I'm just adding it, right? So 3, 1, 0, 0. This guy, how do I get rid of 2? 1 times negative 2. So it's going to negative 2 L3 plus L1 gives me the new L1. So that's going to be disappeared. I'm not going to say kill it. That's what Maria says. It's kind of weird. But anyways, this so it becomes -2. This becomes -2, -3, and that's going to be -4 plus -3, -7, 0, 0. Okay, cool. So that's what I have. Now I have the leading coefficient here. Nothing to compete. Awesome. Here we have got a lot of competition. So let's weed it out. I don't want to use this guy because I already have the leading coefficient here. So it's the next guy's turn. You can choose this guy or this guy. I choose this guy. Again, up to you. It's just I don't want to flip the sign. So anyways, let's have it. So it's going to be next one, 1, 1, 4, 0, because I'm not going to be touching that. I'm happy with this guy. So it's going to be line 2, right? I want to get rid of that guy, right? Plus line 1 equals new line 1. So it's going to be 0, 3, 1, 0. It's going to be 0, 0, right? 3, so plus is 0. Plus is going to be -6, 0. Okay. Now, technically speaking, the whole point doing Gaussian elimination and Gauss-Jordan elimination, which does regardless of which one you use, basically our ultimate goal is to get to the echelon form or reduced echelon form, right? So let's at least try, okay? So the rule, so I'm gonna put this guy on the very top, right? And just before I get confused, I'm gonna write along the way. So line 1 plus 0 times line, oh no, what am I doing? Line 3 plus 0 times line 1 gives me the new line 1. That, and then 0, 3, 1, 0 stays the same, and then it's going to be 0, 0, -6, 0. But you have to move this guy to this guy, just like what I did here. So it's going to be line 1 plus 0, L3 equals to new line 3. Now, this is trivial. I guess you could just say flip it, but I'm just following by the rules, as Maria points out, right? So because of that, I have that, right? Now, is this echelon form or reduced echelon form? Well, because you see right here, this is now a leading coefficient of 1, and there's non-zero on top, right? So this is the echelon form. Do I really want to bother to keep going? Up to you. You may or you may not. This may or make your life simpler, right? But I probably won't bother. I'll just go straight away because it's a use any elimination types, right? And I'm officially out of space, so I'm going to be writing on the side. Okay, so because of that, I'm going to have x plus y plus 4z equals to 0, 0, 0, 6z, oh no, that is -6z, and then 3y plus z. Okay, so if that was the case, then, you know, obviously z is 0. Yes, trivial solution. Okay, and negative, so again, so if that's 0, 3y equals to 0, so y must be 0, and then 0, 0, x plus 0, because anything times by 0 is 0, right? Equals 0, so x must be 0. So this is the trivial solution, where all our trivial solutions, right? Now, before we even do that, you could have done this, but you could have also argued it this way, based on the homogeneous question that we solved just a while ago, right? So how many unknowns? There are 3 unknowns. How many rows? 3 rows. So n minus r, which is 3 minus 3, equals 0, right? So that means there's no parameters or anything of that sort. There are no free variables, right? If there's no free variables, it must be a unique solution. If there's a unique solution, so you could also talk about these if they ask you these side questions. Here we don't really care about this so much because we just want to know what x, y, and z are. But that pretty much gets the job done. So that's the easy one. Do we get more challenging ones? I think we will. 17 is odd, so we don't care. 18. Oh yeah, 18. Okay, I think I lied. These are pretty simple questions now that I look at it. But anyway, let's give it a try. So, okay, so it's going to be, so now we're talking 18. It's going to be 0, 1, 3, negative 2, 0, 0, 0, 0, 2, 2, negative 4, 1, 3, negative 3, 5, 4, negative 1, 2. I'm getting tired. 2, negative 1, negative 4, 3. Okay. There we go. Okay. So, alright. So what we are, remember the crease, so when I flipped it, I did, so for example, here, what I'm going to do is actually switch this first, rather than doing later. Again, it doesn't matter, you could do it now, or you could do it later. I'm just trying to show you all the different ways I might go about with it, right? So if I want to switch from L1 to L2, see, this is what I did one time. So it was a little bit more complicated, so line 1 plus 0, line 2 will become new line 2. I mean, mathematically that makes sense, right? So it makes this all 0 and then just that, right? But you don't have to do that. I just did that, just as to show off, so to speak, right? I could just do this, line 1, line 2, they switch. So if we do that, actually we won't write here. This will be augmented matrix, I was writing, right? Look at the solutions. But basically this is going to be 2, 1, negative 4, 3, and then 0, 1, 3. No, okay. I have to line these things up for consistency. Negative 4, 0, 1, 3, negative 2, 0, 2, 3, 2, negative 1, 0, negative 4, negative 3, 5, negative 4, 0. Okay, now we get to put line 1 and switch with line 2. Okay, so that's done. Next one is what I'm going to do is I'm going to do 2, 1, 1, 0. Okay, good. So now what I'm going to do is get rid of these, right? 2, I like this as a leading coefficient. These 2 are getting in my way, right? Now, come on, think about what Scar would do in Lion King. Great character, by the way. But anyways, okay, I'm getting really tired. I'm talking funny now. Okay, so that's that. 0, 1, 3, negative 2, 0. These 2 I'm okay with. There's no competition. Gotta get rid of these third and the fourth row. So, 2 and 2, how do I get rid of that? Just make a negative of this, add it, and it will become 0. So I'm going to be doing something like negative L1 plus L3 will become the new L3. Okay, so if that's the case, then negative 2, 2, so that's going to be 0. And the next one's going to be 2, next one's going to be 6, negative 4, and 0. Good. 2 and negative 4, so this is going to be non-negative, so I'm going to times this by 2 so that I can get rid of negative 4. So that's going to be, oh no, why am I looking here? I should be looking at here, so my bad. But it's the same idea, right? I'm pointing at the same thing. 2, so 2, trying to get it to negative 4, so 2 times 2, that will work. So 2, L2, L1 plus L4 gives me the new L4. So if that's the case, that's going to be 0, negative 1, 3, 2, and 0. 6. Okay, so that's that. So this row, beautiful, done. Gotta get rid of these. They're causing competition, right? So again, it doesn't have to be reduced, but still, in order to have a basic echelon form, anything below this leading coefficient must have 0 at the bottom. So gotta get rid of these 2, right? So so the top, I'm not really touching because it's not causing me a problem. Second row, again, pretty okay with it. But the second one, the third one, not happy with. So how do I get rid of the third one? I'm gonna do L2 times 2. Negative plus line 3 will give me the new line 3. just to get rid of the 2 here, right? So it's going to be 0, 0, and then negative 2 times 3 is negative 6, 6 cancels out, and then 0, 0, and then this one, all I have to do is just add, right? 1 plus negative 1 will become 0. Perfect, so it's going to be just L2 plus L4 gives me the new L4. So 0, 0, 0, 0. Oh, sorry, yeah. Wait a minute, what happened here? Did I write something wrong? Oh yes, sorry, this is supposed to be negative, folks, my bad. Yeah, it should be right, so let's just double check, let's see if I screw something up. So this is 4th, right? So L1 is, so it's going to be, okay, so let's see, so there's negative 4 times 2, negative 8 plus 5, yeah, that's negative 3. My apologies, that's negative 3. Right. So because of that, it's going to be 0, 0. Okay, beautiful. Alright, so first of all, this is going to have infinite solutions because 4 unknowns and 2 rows, right? Remember, we don't count the 0 rows, right? So because of that, yeah, so because of that, and then what's the, I believe so you have to solve it. So let's solve it now. Oh, damn, sorry. If you get caught off, hopefully, I'm saying the right things to the point where you're like, okay, I can't quite see it, but, I understand what he's doing. So hopefully that's the case. But, okay, so we're going to be solving for this equation. So this guy, right? So I'm going to put 2x plus y minus 4z plus 3w equals 0. And it's going to be 1y plus 3z minus 2w equals 0. The rest is 0 equals 0, so these two don't really help much. Oh no. Oh, yeah, there we go. I meant to go up like this a little. Okay. So because of that, yeah, well, there you go, yeah. Okay, so because of that, okay, good. So, okay, in this situation, we know it's an infinite solution, and we know we're going to have like 2 parameters, right? So, which makes sense, because here I have 3 unknowns, there's no way I can find them. So, because it has 2 parameters, let's just leave one, and then just define these however we want, right? So, let's say I want to isolate for y, right? Y, as an example, it could be z or w. Y seems like the easiest way to go about with this. So it's going to be y equals 2w minus 3z, because I just moved this to the other side, right? So that, and then we get to say w is, again, macro, and the z could be nano, for example, okay? And then both are real numbers. Right? They have, okay, and so that's all we do. So then y is going to become 2, w is macro, minus 3, z is n. That's all there is. Now we have to figure out what the x is, right? So 2x equals 2, negative y plus 4z, negative 3w. I've just moved these 3 to the other side. Divided by 2. Do I want to do that? Okay, yeah. Let's not divide by 2 just yet. I'll leave it till the end. So let's sub it in first. Negative y is supposed to be this thing, right? U minus 3n minus, because there's a minus in front, plus 4z, so 4z, z is n, minus 3 W is the U, right? And that's 2x. So if it's 2x, then get rid of 2 by division, through division. And that whole thing will be the x. You want to simplify? Be my guest. Yeah, I'm going to have to ask this too, whether we need to simplify for now. My gut tells me that no, and really no, right? But the important thing is that we figured out what the possible solutions are, and that's it. That's what matters. 17. I'm feeling maybe this should, I don't have to go through all of them. It's becoming awfully easy. Is there a specific one that is a little funky? Let's see if there's anything that was weird. See, not really. They're all pretty much on the same boat, right? So 22 is going to be the same thing. No, let's skip a little bit and do 22, just for heck of it, right? I want to get to 30 because 30, yes, I understand. We did it with Maria, but she copied the question wrong. So, anyways, my pen is dying. Okay, so let's try 22. 22. So that's going to be, oh, I should change this one a long time ago. Okay, good. So let's try this guy out. Good thing I caught you. I couldn't see. That's 22. Okay, so let's see here. Okay, so one of the first things I did was third row times. Okay, so that's 9. So what I did here is I got the third line, -2, and add to the fourth row to give me the new fourth row, and then same thing, L3 times 1, and add it to the second row, give me the new second row. Okay, so if that's the case, so it says here, 1 stays untouched. Okay, so the second line, what happened here? New second line is third line plus that, right? So it's going to be, we haven't touched the third line either, so 1, 1, -2, 0, -1, 0. Because we're only changing 3 and 4, right? So 1 and 2, they haven't changed, so I'm just going to copy the way it is, right? But the line 2 changes, L3 plus L2, so I got to add the row 2 and row 3. It's going to be 0, and then it's going to be 0, 0, -3, 0, 0. L4 is L3 times -2 plus this, so the 2 cancel out. It's going to be 0, 3, 0, 3, 0. Okay, so that's the case. And then what did I do then? I decided to do the first row. Camera check. Slightly below. Okay, so that's the case, and then I'm going to do first row times 2, and add it to the third row to make a new third row. So first row times -3, add it to the fourth row. That will give me the new fourth. So see the pattern that I'm doing? I'm choosing one of the coefficients and then just destroying the eliminations one by one, right? So after one coefficient is done so that there's no competition, then I look for the next coefficient, which I probably chose as this one because it looks like a nice coefficient, and then now I'm going to be getting rid of negative 2 and 3 as reflected by the new L3, line 3 and line 4 changes, right? So because of that, line 1, I'm not really touching it, so it's going to be 0, 0, 1, 1, 1, 0, same thing. And L2 is not changing, so keep it the same. As a matter of fact, line 2 is probably not going to change anytime soon. The number's as simple as it gets, right? So the third line, that does change. L1, so it was line 1 times 2, and then added to this, right? So these two don't change, right? 0 times 2 is 0, so 1, 1. This one changes, times 2 plus negative 2 is 0. 2, it's going to be 2, 1, 0. And the same thing, the third one, L1 times negative 3. So that's going to be negative 3, negative 3, negative 3. So then it becomes 0, 0, 0, 1, 0, 0. Okay, so that's the case. Do we want to keep going? Well, coefficients here, coefficients there. Now, sometimes what I do is, even though, like, okay, I still want to reduce further, just because it might. If you have, see, look at row 2 and row 4, right? They have leading coefficient in the same place. So, you know, maybe it's an easy cancellation, and it is. It might be saving our time, so to speak. So let's go over this side. So what I am now going to do is cancel one of the line 2 or line 4 out. I'm going to cancel out line 3 because it's negative 3, so it's a bigger number. Really doesn't matter though. 0, 0, 1, 1, 1, 0. Okay, so what I'm going to do is I'm going to get L4 plus, so L4 times 3 plus L2 is going to be the new L2. Yeah, that can be seen, right? So that because of that, L2 stayed up. L2 is going to change. It's going to be 0, 0, 0, 0, 0, 0. Ooh, infinite solution. Nice. Well, I mean, that was expected. But 1, 1, 0, 2, 1, 0, and then 0, 0, 0, 1, 0, 0. Okay. So, I mean, technically we could reduce further. But at this point, I think we're just wasting our time. Well, actually, no, we could probably do this too. Not necessary, I understand, but again, it says use any method, so I guess it really doesn't matter whether we have a perfect echelon or reduced echelon form. But nonetheless, oh no, that's not what I wanted to do. So now here, what I'm going to do is I want to get rid of this leading coefficient here. So. But I don't need to touch here because that looks pretty simple as it is. So I'm just going to get rid of this one, right? So it's going to be 1, 2, 1, 2, 3. So new line 3. It's going to be line 4 times 2. Oh no. It's going to be negative 2L4. So that 1 becomes negative 2. Plus L3 gives me the new L3. Okay. So none of these are affected, 1, 1, 0, and this will disappear, and that's not going to matter, it's negative 0, yeah, so it's 0, so 1, 0, and this is going to be 0, 0, 0, 10, 0, 0. Was this really necessary? Perhaps, perhaps not, but you know, it might help with our calculations. So I'm going to now start doing this. This one's going to be x1, x2, x3, x4, x5. x3 plus x4 plus x5 equals 0. 0 equals 0, so infinite solution is nice, but this is useless to us for our linear equation. This one's going to be x1 plus x2 plus x5 equals 0. This is going to be x4 equals to 0. Alright. Okay, so I'm going to erase the earlier ones, just because we're going to need room. Notice that my voice becomes much softer now. Or not softer, but quieter. This is what happens when you do math for too long. It drives people to insanity. Okay, so we know x4 is 0 already, so let's try to use our process, okay? So because we know this one, we know this one, and so we know x4, so we know one puzzle here, right? So let's start with that. That's a good start, I think. x3 plus 0 plus x5 equals 0, right? So x3 is same thing as negative x5. Now, I just because we use x5 again on this solution, on this is second equation. So if I make x5 to become parameter, it will be so much easier. The reason why I choose that is because let's say I define x5 based on x3. So x3 becomes a parameter. Then x5 is going to be some kind of complicated equation, which is going to fit in here to make a bigger complicated equation. So I want x5 to be as simple as possible. And in this case, infinite solutions, the simplest way to define anything is parameter or 0, right? But we can't define things by 0 just because we want to. So I'm just going to say x5 is macro, where it equals, which is a real number. So if that's the case, then x3 is merely negative macro, right? Now we can look at these equations, right? So it's going to be x1 plus x2. x5 we know, because that's macro, plus macro equals 0, right? Now here is a dilemma. You have x1 and two missing unknowns again, right? So what do? So in this case, we have to make another parameter because it's impossible. We cannot define x1 without knowing what x2 is, and vice versa, right? So we have to just choose one parameter, right? So it really doesn't matter which one. I'm just going to choose x2 as a parameter. So let's say x2 equals 2. Very importantly, it has to be a different parameter, right? So use a different parameter symbol. So let's say n, right? And this is also a real number. So x1 equals 2, n plus u. No, I'm getting very, very lazy. Okay, sorry, my bad. So it's going to be x1 equals 2, negative x2 minus u, right? So then it's going to be negative n minus u. Whew. Okay, so that's actually the end of it. Now you should always organize it. I'm a little lazy, but I should at least try, right? To show you some decent looking solution, right? So x1 is going to be negative n minus u. x2 is going to be n, where is a real number. x3 we pointed out was negative u, and x4 is 0. That's nice. Oh, no. You guys can't see. I'm just, yeah, sorry. So there you go. x4 equals 0. And x5 is, as we said, is macro, and it's a real number. So this will be the solution. Now you can put this in a matrix format, but I think if you want x, y, z, all these are known to be put it into matrix format, I think what they're really looking for is if it's like a trivial or non-trivial solution, so that unknown matches with some kind of a number. When you have equations and parameters, I think linear equation is the way to go to show to define these unknown values. Okay, the rest are still pretty easy. So I want to do something fun. 25, 26,